Okay, so for today's project, I thought it'd be fun to do a viewer request project. I've gotten this request a few times in the past couple of months, which is kind of shocking. People have been asking me if I could rapid fire mod the Xbox One controller, which I thought I would. I mean, there are a few people out there who are, more than a few people out there who are against rapid fire modding. I personally am one of them. I know it sounds hypocritical and I'll own it, but I like modding stuff. It's fun. I mean, I'm personally not going to use this, but I will make it because I like making it. And I will share it with you guys if you want to use it because it's a free country. And if you want to rapid fire something, go ahead. There's a lot of people out there who hate modifications to controllers because it feels as if people are given a certain edge that other gamers don't have. And I think that honestly is kind of stupid. I'm not trying to be mean or hurt feelings, but I think it is stupid. There was a video recently of Ben Heck showing his modifications to an Xbox One controller where he moves buttons around. Now, Ben Heck is a really cool man. He's made modified controllers for people with disability needs or with physical limitations, so he mounts buttons where it's easier for them to push and stuff, and he showed his process of that, his thought process of it, and he got a lot of negative reviews, which I thought was kind of stupid, because, like, he's doing something good. I mean, he's promoting... What I think is he's promoting electronics more so than anything, even though his goal is to show how to make something more accessible to someone who might have physical limitations. So my goal for this video is just to have fun. Like, that's the main goal for this video, just to have fun, because I have the components on hand, I have free time, I got all these shipping parts in the mail that aren't here yet, so I figured why not make a rapid fire video. And simply put, if you don't like it and you don't like rapid fires, don't watch it. I mean, I'm not, like I said, I'm not trying to promote cheating in video games. I didn't say that, but it's what I pretty much implied. I'm not trying to promote cheating in video games, but I'm not the only means of that fix. Like, there's other people out there who mod stuff that people can actually go to. So I'm just having fun with this, and it's just a fun project for me because I tore down this Xbox One controller a while ago. As you may notice, it has a different paint job. That's courtesy of me. I got bored. And I did a Hall effect sensor repair video. I mean, it wasn't really that much of a repair. I just had to put the magnet back in place. And then I did an Xbox One triggers explained video. And in that video, I point out the Hall effect sensors and how they work. And they work by changing the output voltage based on how close a magnet is. And that's how the trigger knows it's being pushed. Kind of like a potentiometer, but not really. And my whole mod focuses on that Hall effect sensor. And I thought it was fun. And I hope you enjoy it. So, I went ahead and soldered up this 555 timer circuit. It's actually a really simple circuit. It just looks like it's confusing. I have an LED here only for a visual proof of concept other than hooking it up to the controller. Now, you may notice it's a little bit bigger than what you would want in your controller. And honestly, I can make it even smaller. I can cut off this part right here, hollow up over here and over here. But I'm not going to because I already know where I'm putting this. Now, as I just said, I painted this controller a while ago, and in doing so, I lost the custom battery backing that I had for it, and that irritates the hell out of me. So I'm not gonna put a white or black battery backing on this, even though it wouldn't make sense because it's black and white camo. But I'm not going to because it would just irritate me personally. So what I've been doing is I've been using this controller with a very long micro USB cable. It just transmits power. And I have no other use for that USB cable because it's like 6 feet long and it'd be useless for charging the phone or anything because of the voltage drop and current drop. But for powering an Xbox One controller, it works just fine, and that's what I've been using for this. And since there's this huge cavity here, I got the fun idea of just putting the rapid fire circuit right in there. Like, it'll fit perfectly. I'll trim up these wires, of course, later. But yeah, it's a really... what I think a really simple solution to putting the chip somewhere, because I don't want to hollow out the controller by any means, and I want to be able to remove this if I have to, because this is one of my main controllers, but not really. I use a nano controller more so than anything. This is just a fun one, and I figured I'd mod it just for the pretty much the purpose of having a video to put out and just for fun. So let's look at this circuit a little bit better. First we'll go to the whiteboard and I'll explain how it works with the Xbox One controller. Alright, so here is the 555 timer circuit on my whiteboard. And here's a close-up of the circuit I was showing you in the previous clip. You didn't really get a good look at it because of the distance, but it's actually Very simple. I got a potentiometer here that's just for pretty much tuning the output. And before the potentiometer, there's a resistor going to its wiper, so there's a constant resistance even if you go too low. That really isn't needed, but I threw it in there just because. And then yeah, 2 transistors right here, which will be used for the Xbox One controller itself, the left and right trigger. I may only do the right trigger in this video, but the transistor's there for the left if I so please. And the 10 microfarad capacitor. Now, 555 timer works in a very simple way. It can output a square wave, just like this one, which is astable, or it can output just one pulse, which is monostable. For a rapid fire controller, you want a constant output, which is a astable 555 timer circuit, which is what I got here. So the output of it is determined based on the components and the values of them. In doing that, I got a very fast output pulse, which is similar to this little square wave right here that I drew up. It's kind of a sloppy one, but it's good for representation. So when the 555 timer is powered up, it outputs a square wave pulse like this really fast. And my goal is to run that through the Hall effect sensor of the Xbox One controller. Now for visual proof, I got an LED soldered in place. I more than likely will get rid of this eventually because it might be annoying, but that's just there for now to show that it's still working without having to probe it or anything. Here is the Xbox One Hall effect sensor. Very simple circuit diagram that I drew. On the Hall effect sensor, you may remember there's only 3 pins. There's a voltage input pin, a ground, and an output. Now, when the magnet gets close to the Hall effect sensor, the output actually goes lower, so that's how the triggers know it's being pressed. Now, in my Xbox One teardown video, I tested for fun just shorting the output pin to ground to see if it would register a trigger being pressed, and it actually did. So my goal for this is to run a wire from the output pin through the collector of the 2N3904 transistor and to the emitter to ground, which will pretty much turn on and off the trigger really fast via the square wave right there. So I'm going to hook this whole circuit up to my breadboard right now so you can get a visual proof of it, and then we're going to move to the Xbox One controller itself and solder to 1 Hall effect sensor. I might do 2 in this video, I'm not entirely sure yet because I'm only limited to 1 tactile switch right now, which is very sad, but I can only find 1. So it might have to suffice for now. Now, a little more on this potentiometer before we switch over to the next clip. It's a 150K potentiometer. I could have got away with a lower resistance value, but I didn't. This is the one I used, breadboarded with, and turned out with, so I didn't want to really screw around with it because it worked. So this pin right here, there's 3 pins on a potentiometer, or in this case, a trimmer, and in this case, I used the wiper pin to go to pin 7, and one of the output pins of the potentiometer go to pin 2 with the inline resistor. Now there's 1 pin that's not used, and that's represented right here. Just simply clip it off if you want to or not use it. And the resistor values for the potentiometer is 150K. The base resistor for that, or the inline resistor rather, for the potentiometer is 2.7K. Probably could have got away with a 1K if I wanted to, but didn't want to. That makes sense. And then 7 to 8 is a 1K resistor. And then we got a capacitor right here, which is 10 microfarads. Pin 5 on the timer is not being used because it doesn't need to be used. I mean, I could solder that to ground with the capacitor, but didn't need to. And then over here, I think I have a 150 ohm resistor going to the positive lead on the LED. I'm not entirely sure on that. It may be less or more, but 150 ohms would work. Anything with 100, like my guess is 150 ohms to probably about 400 ohms will work just fine with this LED. And on my circuit board, you see 2 transistors right here. I only drew 1 for simplicity, so this right here represents 2 on the board. We have a 1K resistor going to the base on each transistor, and the transistor I used is a NPN 2N3904. Very cheap transistor, and I had a lot on hand, so I used them instead of my more expensive other transistors. And that about sums up this circuit, so let's move on to my breadboard, or basically a power supply, and I'll show you this guy working via the LED. Okay, so here it is on my breadboard. I have a simple power supply hooked up to it, just 5 volts, running on the far left rail. Not that that's important, but here is the LED flashing, proving that the 555 timer is outputting a square wave pulse. Now, if I adjust the potentiometer, I can adjust the output of that. So let's adjust that real fast. So I can go really slow. Not that it's necessary for a rapid fire controller, but that's how slow it can go if I wanted it to go that slow. And then let's go as fast as we can, but with increments. So it could be that fast if you want it to. And we're going up. It could be that fast, that fast, that fast, or the absolute fastest, which is that. I mean, you could barely see it flicker, but that is the absolute fastest of it, which is a pretty fast trigger pull, I think. Okay, so real quick, we're back at the whiteboard because I want to clear up something real fast. For those who are familiar with electronics and for those who are familiar with the 555 timer, you will probably know some functions of it that a lot of people don't. For example, if there's no output pulse on pin 3, it actually goes to ground. So in a sense, I don't need transistors to do this mod. I can actually do it with... Sorry for my shaky hand. I can actually do it, let's say this is pin 3 right here, just for example. I can actually do it with a simple diode in this fashion, and that going to the Hall effect sensor pin. Now how this would work is the output pulse of the timer would go to this diode and always go high. Now current can't flow the other direction, but every time it goes high, it disconnects from ground, and when it goes low, it will allow this diode to go to ground, which will let the Hall effect sensor know the trigger is being pressed. So it works the same way. I personally didn't want to go this route because I didn't breadboard with diodes. I just breadboarder with transistors. I had a suspicion that the diode wouldn't work as fluidly because when it's not being pushed, it will go to ground by itself. So I didn't really know if that would false trigger anything, but this is a definite possibility for this. Like, you can do this method instead of the transistor method with a few controllers that register by buttons going to ground, pretty much. Like the NES controller does that. So this has a few applications. I'm just personally not using it for this. So yeah, let's move on to the Xbox One controller now. Okay, so I got the 555 timer circuit soldered to the Xbox One controller. I got the switch in line right here. It's just in my gator clip. Sorry for the sunlight. But it's just a little tactile switch, single pull, single throw. Nothing special. Now, for power supply, let me just close my curtain real fast. The sun is blinding. It's better. Slowly creeps open. Now, for power supply, the timer has to go high to the voltage. For me, I'm using a micro USB cable, which is 5 volts, so it has to go high to 5 volts, which is off of the micro USB itself. So I actually found a capacitor that I soldered that wire to. I'll give a better picture in a minute. It'll be probably in the corner. So I soldered the positive wire to that capacitor because that's where I read 5 volts. I just soldered the ground line for the timer circuit to the ground on the battery contacts. I clipped those off because, like I said, I'm only using this as a wired controller. I don't care about the batteries because I'm not going to use batteries for this controller ever, simply because I lost the battery pack or the battery backing. I'm picky like that. And here's the switch right here, like I just said, and it is going to the Hall effect sensor output pin, which is right here. It's this tiny little, very tiny SMD component right in front of my finger. I'll give you a better picture of that, but also I will do you one better, and I will draw you what it looks like on the controller itself. So for it, I mean, the Hall effect sensors are mirrored, so this one right here represents the left trigger, but for the right trigger it looks like a little rectangle with 2 pins and 1 pin. This is what it looks like for the right trigger. This is the pin you want to solder to. This is the output pin. So that's the pin you want to solder the wire to from the transistor, which is going to the collector. So the collector goes here, and in between that, let me just draw it real fast. In between that you have, get a better view of that. In between that you have the button, and then it routes through the transistor itself, and then closes to ground. So that's a very simple very simple way of doing it, a very easy way to show you. Like I said, there will be better pictures, like you probably already saw them, because I don't really plan ahead while editing, but this is the best way to do it, and this transistor obviously goes to the output of the 555 timer circuit. So I'm going to do some hot glue on the wires to really make sure they stay, because I used really thin gauge wires, and then we're going to test it out and see how it works. Alright, so I got everything in place. I just used some double-sided tape to stick that circuit board in place. Now, some of you may not like where the circuit board is placed, but keep in mind, you can move it anywhere you want. I just had extra space, and I went with it, and I personally like it. I think it turned out great because I like it when circuits show. I just love that. But yeah, I didn't really feel like hollowing out the controller or doing any weird stuff like that because I didn't need to. But yeah, there it is. You can see the LED flickering. That means it's working. And I mounted the push button, little tactile switch right here next to my thumb, so my finger sits on it just fine. So yeah, we're going to start Call of Duty right now and find out if it works. First official test. I only have one screw holding this controller in. So we're going to switch over, make sure the trigger itself still works, which it does. Switch hands real fast, and then we're going to... Alright, beautiful. Yeah, that's pretty fast, I'd say. That's the fastest it can go. Yeah, that is perfect. Alright, so I'm going to close the controller up and... Okay, so I have the whole thing assembled again, and it is done. Works awesomely. I mean, it works a lot better than I thought it would. It's really fast. I love it. But yeah, that's the end of this video. Thanks for watching again. This project was just for fun. I'm probably not going to use it because, like I said, I use my Nano controller. The only time I'll ever use this is if, like, I'm playing with friends at like a LAN match or something. But right for everyday use, not going to use it because I don't like it. I like the Nano controller a lot better. And if I wanted to rapid fire the Nano controller, it'd be a lot easier than this one because it's made like the 360 controllers. There's like no surface mount parts with the solder to in the 360 controller, but this was like all surface mount crap. So this was a lot harder than the Nano could have been. But yeah, I mean, it's all done. I will add a second button over here through the transistor once I get more tactile switches in the mail. They are coming. But that is the end of this video. Thank you for watching, and subscribe if you like what you see. I try to do as many videos as I can. I want to get on a weekly or bi-weekly basis on videos, but I don't have the time nor the funds really. But my goal is to be more consistent with videos and content. So be sure to subscribe if you like what you see. Also check out my other videos of recent past. And thanks for watching.